everyone, my name is Nur Ismahani from Class E. Today, me and my teammate will be presenting about application of differentiation, applied maximum and minimum. First thing first, let me introduce you to my amazing group members. In this group, we have Ainul, Haziq, Adam, and me, Isma. Now, let's move on to our lesson. What is differentiation? Differentiation is a method used to compute the rate of change of a function f(x) with respect to its input x. The rate of change is known as the derivative of f with respect to x. Applied maximum and minimum. Why do we apply maximum and minimum? In real life, it's usually used to maximize the profit in a company or minimize the cost to make a particular object. Meanwhile, in calculus, it's used to calculate the highest and lowest point of the curve in a graph or to know its turning point.
Problem statement. A rectangular billboard is being built such that its height, h, and width, w, are constrained by a total perimeter of 60 meters. To make the billboard aesthetically pleasing, its area, A, must be maximized. Question A. Express the area, A, of the billboard as a function of W, given the perimeter constraint. Question B. Find the dimensions of the billboard that will maximize its area. Question C. Determine the maximum possible area of the billboard. Solution. The perimeter of the billboard is given by 2h plus 2w equals to 60. Now we solve for h in terms of w. H equals to 30 minus w. The area of the rectangle is A equals to h multiplied by w. Then we substitute h equals to 30 minus w into the equation for area. So it will become A equals to w multiply in bracket 30 minus w. Then we simplify the formula into A equals to 30w minus w square. Question B. Find the dimensions that maximize the area. We have dA over dw equals to 30 minus 2w. Now we let dA over dw equals to 0. 30 minus 2w equals to 0. Now we rearrange it and it becomes w equals to 15. Now we insert w equals to 15 into h equation. It will become h equals to 30 minus 15. Then we get h, the height, equals to 15. The dimensions that will maximize the area are w equals to 15 meters and y equals to 15 meters.
Now, question C. Determine the maximum possible area. Substitute y equals to 15 and h equal to 15 into the area formula. So, A equals to h times w. So, it becomes 15 times 15 equals to 225. So, the maximum possible area of the billboard is 225 meters squared.
Here is another example of situation that apply calculation of maximum and minimum. A box with a square base has no top. If 64 cm square of material used, what is the maximum possible volume for the box?
In this equation, it is best to sketch the net of the box first. As you can see here, based on the sketch, the width and length are labeled as x, while the height is labeled as y. After that, we need to find the value of y by using the equation from the total area, because we only want one variable, which is x. As you can see, the area of this box consists of one square with side length of x and 4 rectangles, each with length x and y. Hence, the area of this box can be written as x squared plus 4xy equal to 64. Hence, y is equal to 64 minus x squared over 4x, and the value of y is equal to 16 over x minus x over 4. The formula for the volume of a cuboid is length multiplied with width multiplied with height. Hence, the volume of this box, V, is equals to x squared y. We don't want y in the equation, so we substitute the value of y that we found earlier into the equation. This gives us V is equals to x squared multiplied with 16 over x minus x over 4. Therefore, the equation for the volume is equals to 16x minus x cubed over 4. Next, we need to find the possible value of x that will maximize the volume. To solve this, we first need to compute the first and second derivatives based from the equation of the volume. For the first derivative, dv over dx is equal to 16 minus 3x squared over 4. And for the second derivative, d square v over dx squared is equals to 0 minus 6x over 4. After we simplify it, we will get d square v over dx squared is equal to negative 3 over 2x. Then, let the first derivative, which is dv over dx, equals to 0. Hence, 0 is equals to 16 minus 3x squared over 4. X squared is equal to 64 over 3, and the value of x would be 4.6188 and negative 4.6188. Next, substitute the value of x into the second derivative equation, which is d squared v over dx squared equals to negative 3 over 2x. As you can see, the result when we substitute x equals to 4.6188 is negative. Hence, x equals to 4.6188 is the maximized volume. Meanwhile, the result when we substitute x equals to negative 4.6188 is positive. Therefore, x equals to negative 4.6188 is the minimized volume. And now, we can do the last step. To find the possible maximum volume of the box, we need to substitute the value of x that will maximize the volume, which is x equals to 4.6188 into the volume equation that we derived earlier. Hence, v equals to 16x minus x cubed over 4 would be v equals to 16 multiplied with 4.6188 minus with 4.6188 cubed over 4. And the final answer will be v equals to 49.2672 centimeter cubic.
Conclusion. In conclusion, the application of differentiation in finding maximum and minimum values is essential in solving problems. Through this presentation, we have explored its practical application, calculating slopes, finding maximum and minimum, and understanding motion.